We're teaching the basics of scripting in Unity in C# to make our own custom components. Special thanks to our patrons at the time of recording. Grab your Red Bull, grab your Golden Sun Affinity class chart, and let's get ready to start. Let's start off with our plane object as a ground object. Let's go ahead and make sure that it is in our vector 0 position, so that's 0, 0, 0. Let's make a capsule object, and we're going to call this capsule player. And we're going to make sure that that's at vector 0 as well, and then just lift it just above the ground. So if we zoom in on it, it's just above the plane. Let's go one high, and we'll just change our plane to be a little bit wider. Let's say 3. And let's make it 10 is fine, but we'll just move it so that it's at the end, just a little bit off. And then we'll just grab a material. Let's rename cube to player. And just put that on ourselves, and there we've just got a very quick scene set up where we've got a player and we've got some ground in front of us. So let's go into our scripts folder and let's right click, create Monobehaviour Script. Monobehaviour refers to the default behaviors that come with Unity. Unity comes with a bunch of components and scripts, and we can write our own custom scripts to act as components. How we do that is that we make our scripts inherit from the Monobehaviour class in Unity. For now, we're just going to create a script and we're going to call this player controller. Just again quickly, I am zoomed in a little bit just for the sake of the video. When it comes to creating Monobehaviour scripts, this is the default start of what they look like. It comes with two methods, the class itself, and then a namespacing area up above. Up here we can actually get rid of these two methods, and then we've just got our namespaces using Unity Engine and our class here. Really quickly, we're going to talk about the naming rules of classes. Basically, when you create a class, you have to declare it. Declaring a class involves three things. It involves visibility, a type, and then we come up with our own name. And then that is followed by two squiggly brackets. A pair of squiggly brackets define a body of code. When we declare a class, there are a couple of naming conventions, as I said, especially if you're declaring a Unity component with a Monobehaviour. So while I've got my name here, player controller, right after it I've got this colon, and then I've got the word Monobehaviour. That means that this class that I'm creating is inheriting from another class called Monobehaviour. This class is provided to us by Unity, and all the behaviors and methods that the Unity class can do, now our player controller can do it as well. For this to work and for it to appear as a component in Unity, it needs to inherit from Monobehaviour, and also the name, player controller, needs to be the same as our symbol's name, which is the file in the actual project window. As long as the file and the class are the same name, and we inherit from Monobehaviour, and this class is the first class in the file, it'll all work perfectly fine. Now let's think of a class as a container. And within this container, each piece of data is a Lego piece. And we're going to break all of those Lego pieces down to their core types. Now if you press // you'll actually get to write comments in your code. Now the core types are int, float, string, and boolean. An int is a whole number, a float is a decimal number, a string is a series of letters or words, and the bool is a simple true or false statement. Almost everything in a game is made up of these four basic types. You can create your own data types, but when you do, you'll find that those data types usually just consist of these four. Alright, so now we have a class, but the class has nothing in it. We need to think of this component as a container of data types, so we're actually going to fill it with some variables. Let's go ahead and declare our variables. We're going to start with private variables. There are different kinds of visibility for these variables, but for now we're just going to do private. When we do that, we need to think of a couple of things. We need to think of our visibility, let's say private, as we said. We need to think of the type, let's say int, and then we need to give it a name. When declaring private variables, naming conventions say that you should start with an underscore and then go camel case from there. So we're going to say times jumped, and we're going to make it equal to 0. Then we're going to end our line with this semicolon here, so that C# and Unity knows to stop thinking about this line. This is a declaration. We've got our visibility, we've got our type, we've got our name, and then we've got a value for that variable. This is a default value. We're going to do that again with the other types. The next one's a private float. We're going to call this one jump height. Let's set it to about 0.6. Now you'll see I've got an error here, even though this is a decimal number. That's because when you're entering a float, C# and Unity just like that you throw an F at the end of your decimal number. Next we're going to have a private bool, and this is going to be can jump, and this is going to represent whether or not our player can jump. And let's go ahead and default this to true. And then we're going to have our private string, and we're going to call this one winning message. Congratulations. So here we have 4 variables set up, and what I've actually done is made them private, and I've hard-coded their values here. I don't usually hard-code, and it's not a good idea if you're working with other developers. I wouldn't define these values here as default values. I would actually just leave it like this with this part cut off, and then I'd make it so that you can edit the values in the editor. I will show you how to do that in a second, but for now, let's just continue with our hardcode. Now, we are actually able to rename our variables by highlighting our variable name, hold Control, and press R twice. This brings up this little window here that lets us rename the variable. We can basically change our naming convention here if we like, say times jump in sentence format. The reason we do it through this window is that this actually searches all of our other scripts in the project, as well as the project itself, and finds any references where this name is used and renames it in that location as well. If you didn't do it this way and you just typed times jumped over it and walked away, it wouldn't rename the reference in other files, and you'll get a whole host of errors. Now these variables, like I said, are Lego pieces. Thinking of this class as a container of Legos, we can actually make those Lego pieces do things. To do that, we're going to write a method or a function. So when we write a method, we need to declare it. A method or a function is returning something to you by performing an action. I'm going to tell our class to do something, so we're going to go ahead and declare our methods the same way. We need to think of our visibility, so let's say public this time. And when I'm writing a method, our return type is void. Then we're going to give it a name. When naming methods, just use normal punctuation, so capital letter. We're going to call this one jump. At the end of the name, you need to put a pair of invoking parentheses. This pair of parentheses is letting the system know that we are invoking this method. We're asking it to do something. Underneath our declaration, we need to put 2 squiggly brackets. Everything inside these 2 brackets is part of our method and part of its body of code. So we have our public void jump, and it's going to do something. What we're going to do is we're going to make the player jump. Now let's talk about visibility again. Let's talk about the differences between private and public. Everything inside this class is a piece of information, including the method itself, as well as our variables. If a variable was private, then the only thing that has access to it is the body of code it belongs to, which is shown by squiggly brackets. If it's public, any other body of code, script, or component can access that information as long as they have a reference to the containing class. Then they can just put a full stop behind that class to drill into the container and get the information. So public is visible from anywhere if you have a direct reference. Private is invisible and only the containing body can read or change it. So as all good game devs, we're going to test that our script works. So we're going to use our debug.log method. Debug.log is a method that sends a message to our console, as long as we put our message inside these invoking parentheses. Debug.log, I'm going to write a string here by using quotation marks. Make the player jump. Then we're going to go debug.log. The player has jumped. and we're going to put in our jump height to string. This is a method that converts floats and ints into strings. Add units. Now this looks a little janky. While I've written this string here within quotes so that it's just straight words, I've also written this float and converted the float to a string as well. Then I've connected them by these two plus symbols. This will actually translate to the player has jumped 0.6 units. Why do I know it's going to say 0.6? Because I've used our jump height variable, which we know is equal to 0.6, and we've converted that float into a string. We're going to add some other debug logs around here as well, so we can make another debug log say, can our player jump? Answer, and then we're going to connect our bool can jump. Now that I've inserted a bool here, this bool will convert to true or false within the context of a string. So this will say, can our player jump? Answer, true. Now our next debug log is saying that we have jumped and we want to show how many times we've jumped. So we're going to say we have jumped, times. Now this is going to be our first error, and you can probably get ahead of me and see what the problem is going to be. This is going to translate to we have jumped 0 times, which isn't going to be true in this context. We want this to say we have jumped once. But we know because from when we declared the int, we set the default value as 0. So how do we change the value of a variable somewhere else? Well, before the debug.log, we're just going to write times jumped plus equals 1. Now the reason we do plus equals 1 is because the math components we're using is a little different in C#. Operators also have to define the variables by setting them. So instead of just times jump plus 1, we need to say plus equals so that it means plus itself plus 1. We can also do minus itself by 1, times itself by 1, and divide itself by 1. So those are basic operators for math when we're using ints and floats. In this case, we do actually have one more that is better for this situation. We could do times jumped and just put plus plus. Now, as an operator, plus plus just increases the value by 1. So, times jumped plus plus is equal to times jumped plus equals 1. We know that this is going to say x, where x is equal to how many times we've jumped. And then finally we're going to do one more debug.log that's going to say our winning message. Like I've been saying, we need to pass a string into these parentheses we see up here. I've declared this string already, so I can actually throw the winning message variable into this debug.log and it will also work. Now we've set up our first method, and all it does is test a bunch of things through debugs, and it tests a little manipulation that we've made to a variable. How can we get this to happen in our scene? Well, first of all, we need to attach this script to a game object in our scene. So back in Unity, we've got our script here. We're going to go to our player object, and we're going to add our component. This component is going to be the player controller that we've just created. So we see our player controller component appears here. There's nothing to edit on the component itself, and if we press start, nothing is going to happen. That's because there is nothing calling or invoking this method. The method has 0 references. Nothing is telling the script to jump. So we're actually going to create a way for us to do that in the editor. And how we're going to do that is by creating an attribute. An attribute is a keyword that we put in a square bracket before a method or a variable that changes how that variable functions. And this attribute we're going to use is called context menu. And after that we're going to put a parentheses, and we can see for context menu to work we need to insert a string, and that string is called the item name. So in here we're just going to put jump test in quotes, and that's going to be the name of our test button. So we can save that and we can go back into Unity, and if we right click on our component, at the bottom we now have an item called jump test. and that refers to this method on the script. So now if we enter play mode and we open up our console, if I right click on our component and I say jump test, we see all of our debugs happen. Make the player jump. Can our player jump? We know this is equal to true. The player has jumped 0.6 units. We have jumped 1 times. Congratulations. So that's worked pretty much exactly how we wanted it all to work, but we did notice that nothing happened in our game window. As a designer, we might want to change all of these without going into the script itself or without editing the component themselves. There is a way to do that, and it's the difference between public and private visibility for variables. So I'll show you that now. Now, if we take our declaration of these variables, and we can change them to public, so let's go ahead and change all of them to public and click save. Now if we go out of Visual Studio and back into our editor, we can actually see that our component is filled with these properties. We now have a times jumped field, a jump height field, a jump bool, and a winning message string field. And we can actually edit these variables ourselves in the editor. So let's go and make our jump height to 1.2. Let's say we can't jump, and let's change our winning message to you couldn't jump. Now when we press play, and we test our method again, jump test, we see that our debug log messages change. Make the player jump. Can our player jump? False. This is false now because we changed it over here. The player has jumped 1.2 units. We have jumped 1 times. This is technically wrong. You couldn't jump. That's our new message. So by switching our private variables to public, our Unity editor can now see them, serialize them, and we can edit them here in the editor. Let's change them back to what we had. Now that these are public, they do have different naming conventions, so we can get rid of these underscores now. And you'll see that once I delete these underscores, our method becomes full of errors. This is because I didn't use the renaming technique I mentioned earlier. So let's put all of these back to clear these errors. Let's select our names and hold Ctrl-RR to rename them. Removing the underscore here, you now see removes the underscore in the other references to the variable as well. I can also choose to include comments as well, and it will change the one in our comments.
Thank you for watching, everybody. My name is Taryn Game Dev. I'm a game developer and my game is Tales of Tall Rest. The amount of attention and support it is getting allows me to make videos like this. If you want, you can go and check out the game on itch.io, follow me on Instagram to see all the updates and how the game is going, and if you'd like to support me, you can support me for even $1 or buy me Red Bull once a month over on my Patreon in order to get all these videos weeks before they come out here on YouTube. Thank you so much, guys.